IRIMEE this opportunity. Today I'm here to take the overview session on MEMU three-phase control system. For this product, from MEDHA point of view, we have given the type name as MEE675M. Am I audible, sir? Please give anyone response.
Yes, sir.
Yes, sir.
Right, sir. Thank you. Thank you. So this MEE675M. MEE675 is a MEDHA mainline AC EMU traction control system for AC transmission. So this last M suffix stands for MEMU control system, right? So here, as we know, this MEMU is working in Indian Railways from long back. Even earlier, conventional MEMUs are working with the AC DC transmission system. But from 2017 onwards, Indian Railways, ICF manufacturing three-phase MEMU traction control system with AC transmission. And as we know, this MEMU is mainline electric multiple unit. And as per RDSO and ICF, this MEMU train car formation is by default, it is of 8 car formation or 8 coach formation with 2 basic units connected back to back. 2 basic units. And further, we can connect up to 4 basic units, 16 car formation. Each basic unit contains 4 coaches named as DMC, TC, TC, TC. Driving motor coach और बाकी 3 जो है trailer coaches, TC. So out of 4 coaches, 1 coach is provided with motorized axles. Because of that, we'll call here it as 25% motoring concept in MEMU. 25% motoring concept means out of 4 coaches, 1 coach is provided with traction motors. 1/4 or 25%, right? Next, provision, like already discussed, maximum 4 basic units we can connect as per the end user requirement where we are working this train. And this CRW panel, true rear wall panel or cab rear wall panel, auxiliary compressor, traction converter, auxiliary converter. So these are all placed in HT compartment in DMC coach. Just back to the driver cabin, there is a HT compartment, high tension compartment in DMC coach. In that HT compartment, this traction converter, auxiliary compressor, and CRW panel facing towards driver cabin. All these equipment provided. Out of this, except auxiliary compressor, remaining CRW panel, traction converter, auxiliary converter, these 3 major subassemblies are from MEDHA. Auxiliary compressor or baby compressor is from railways. And when it comes to DMC underslung, this traction transformer, main air compressor, battery bank, all these mounted under the DMC coach, underslung of the DMC coach, driving motor coach. Next, coach electronics distributed in all the coaches for individual coach passenger comforts related control. Passenger comfort related controls means like lights control, fans control, EP brake control, air suspension bellow control. So all these comes under passenger comforts. So for passenger comforts control, coach electronics is distributed in all the coaches. सभी coaches में जो है coach electronics in provided in end wall panels, EWP. Each trailer coach is provided with 2 end wall panels. So उन दोनों end wall panels में this coach electronics जो है provide किया है. So this is just overview. When it comes to this basic unit, here we can see this DMC, TC, TC, TC. 3 trailer coaches with a driving motor coach. So only driving motor coach is provided here with motorized axles. That's why shown in black color. So motorized coach is only DMC, remaining 3 simple trailer coaches. And DMC coach only is provided with roof equipment, onboard equipment, and underslung equipment. Remaining only coach electronics is distributed in all the individual coaches. तो यहाँ पे ये 4 coaches को मिला के एक basic unit कहेंगे. And when it comes to rake formation, as per standard, it is 8 car formation. So 2 basic units connected back to back. And out of this, only this DMC2 coach is rotated by 180 degrees. All these trailer coaches and DMC1 coach in one direction, and DMC2 is rotated by 180 degrees to get the driver cabin opposite direction. So both ends bidirectional train. So as usual, like train sets, other train sets. So this MEMU also can run in both sides. So for that purpose, only DMC2 coach is rotated by 180 degrees. Okay, this is rake formation. So out of 8 coaches, 2 motor coaches, 2 by 8 or 1 by 4, that is 25% motoring concept. Okay. At any time you can raise your points if you have any queries. So without any hesitation, please unmute your mic and you can raise the point. Next, when it comes to this power scheme, this power scheme is applicable only to DMC coaches in MEMU. This entire power scheme is placed in driving motor coach. So right from this, from OHE, overhead equipment energy, 25 kV, single phase, 50 head supply. Once if pantograph raised and VCB closed, the supply comes to this traction transformer primary and opposite through axle wheel rail, the return path will get closed. This small dotted block is called traction transformer. This we are not manufacturing, we are taking it from outside like pantograph, VCB, surge arresters before VCB, after VCB, AC earthing switch. These are all we are taking from outside. And all these equipment up to this surge arresters, they are placed on the roof of DMC coach. And DMC underslung is provided with this traction transformer. In MEMU, we are taking this traction transformer from ABB or Siemens. Siemens make or ABB make traction transformers, oil cooled traction transformer, which is of 1250 kVA rating, 1250 kVA rating traction transformer, which is provided with 1 primary winding and 2 secondary windings. When the input OHE voltage is 25 kV, each secondary winding produces 950 volts single phase 50 head supply. There is no any connection between these 2 windings. And the single phase AC output from the traction transformer directly given to LTC, line and traction converter. This bigger dotted block, this is LTC, line and traction converter. Air cooled IGBT based line and traction converter from MEDHA, which is placed in DMC coach HT compartment, high tension compartment. This is 1300 kVA rating, air cooled IGBT based converter, and this is physically placed in the HT compartment. From the 2 windings of traction transformers, the supply comes to each line converter. Here we can find these are IGBT based line converter. So in the initial, for the first time, system energizes this precharging contactor, so that through precharging circuit, it starts converting this single phase AC into DC. And whenever it reaches to 90% of the required voltage, system energizes the main contactor, so that these 2 contacts will get closed and both the line converter starts working. And the function of this IGBT based line converter is to convert single phase AC into DC, constant DC with unity power factor at input side. So the line converter function, it rectifies and maintains constant at 1800 volts DC, 1800 volts DC with unity power factor at input side. That is the function of this two line converters. And both the line converters output connected in parallel. This negative is connected here and positive is connected here. So both the line converters output connected to common DC link. And this DC link will be always maintained at 1800 volts for normal operation. And to suppress any AC ripples which is available in the DC link, for that purpose, this capacitor bank is provided, DC link capacitor bank. And the pure DC will be given further to traction converters. And here further this brake chopper circuits. Brake chopper circuits are for over voltage protection to provide the safety from over voltages. Generally, DC link should be 1800 volts for normal operation. Because of any abnormality, if this voltage shoots and touches to set value, जो set value है 2100 volts. Whenever it reaches to set value, then system triggers both of these IGBTs so that these resistors, brake chopper resistors, acts as additional load on the DC link. And because of that additional load, the over and above voltage will be choked. And whenever the DC link comes back to normal operating range, both the brake chopper circuit will be disconnected from the DC link. So this brake chopper is for over voltage protection. Okay, at any time, either motoring or braking, whenever the DC link reaches to set value, that set value is 2100 volts. Then these brake chopper circuits will come into picture and it shows the over and above voltages, right? And further, there is a earth leakage detection circuit, ELD. In power circuit, in the DC link, either positive side or negative side or traction transformer secondary side or traction motor side, anywhere in the power scheme, if power circuit is touching with the body, leakage current is flowing, then that leakage current will flow through this earth leakage detection mechanism. And whenever the leakage value reaches to set value, then system cuts off the traction with appropriate fault message. So one basic unit will get disconnected from the overall rake power. Okay. So this is about earth leakage detection, power circuit ground detection point.
Rajesh sir.
Yeah, yes, sir.
I have one doubt.
Yeah, please.
Chopper will come in circuit.
Sir, your voice is low, sir. Please increase the volume.
Sir, that brake chopper will come in circuit, no, sir? That time any event will come, sir.
Brake chopper?
That brake chopper, when it will come in circuit during a pressure,
yes,
over voltage, is there any log or event will come?
Yes, yes. Yes, exactly. You can find a message on the display and as well as internally it logs the message that brake chopper fired.
Oh.
Date and time stamp. Yes, exactly. Okay, sir. Okay. So whenever brake chopper or any event other than the normal operation occurs in train, then automatically it logs with the date and time. And the same will be indicated on DDU also, driver display unit, and internal recording also is there. So in during analysis, we can retrieve the data and can analyze further, right? And further pure DC, after this brake chopper and ELD, the pure DC will be given to two traction converters. Both of these are IGBT based traction converters. These converters convert DC into three-phase AC as per the computer commands. And this output, we'll call it as VVVF, variable voltage, variable frequency output. The voltage and frequency both can vary as per the requirement, either voltage or frequency or both. And this voltage varies from 0 to 1430 volts and frequency varies from 0 to 160 hertz. And each converter output, as it is a bogie control system, as per train sets standard, it is bogie control system. So each converter output will be given to two traction motors. So in truck bogie 1, TM1, TM2 from traction converter 1, and in bogie 2, TM3, TM4 from traction converter 2 gets the supply. So this is about the power scheme. And in HT compartment only another unit is there, which is called auxiliary converter unit. And this is again purely from MEDHA. This is also placed in the HT compartment just beside the line and traction converter. And this is 120 kVA rating auxiliary converter, 120 kVA rating. And the function of this auxiliary converter is to convert DC link supply 1800 volts DC into 3 different low voltages: 415 volts 3-phase 50 Hz supply, 110 volts single phase 50 Hz supply, and 110 volts DC supply, which are required for the operation of all the auxiliary loads in the train. Okay, so that is about auxiliary converter. This is also from MEDHA. And when it comes to these traction motors, these motors are AC induction motors or asynchronous motors. And these are 268 kilowatts continuous rating motors. Continuous rating up to 268. We can load short-term ratings up to 350 kilowatts. But continuous rating is 268 kilowatts, asynchronous or induction motors. And these are also from MEDHA. We are manufacturing here in Hyderabad with a joint venture. Technology is from one Austrian based company called Traction System Austria. With their technology under joint venture, we are manufacturing the traction motors here in Hyderabad premises. Okay, and all these traction motors are from MEDHA. 268 kilowatts continuous rating, self-ventilated, no suspended motors. In regular MEMU and EMU, self-ventilated, no suspended technology we are using. So this is the power flow from OHE to traction motors during motoring. But when it comes to braking, in general, this train is equipped with EP brake system. But in this, additional one more feature is there called electrodynamic brake. When operator wants to stop the train by applying the brake by using master controller handle, master controller handle or throttle handle will be used for braking. Then system applies electrodynamic braking first, and then if that braking effort is not sufficient, it takes the help of EP brake. So both electrodynamic and as well as electro-pneumatic brake, that combination in general we'll call it as blended braking. Okay, blended braking or brake blending. In braking, these freely rotating traction motors, in general, continuously we'll measure the rotor speed, and in dynamic braking, system keeps the stator frequency less than the rotor frequency, rotor speed. So in that fashion, these freely rotating traction motors acts as generators, and these traction motors produce 3-phase AC supply. That comes to the traction converters, where this traction converters acts as rectifier. During motor, same converters working as inverters, but during braking, these traction converters acts as rectifiers and convert this 3-phase AC supply into DC, and the traction converter maintains constant 1800 volts DC. That is the function of traction converter during braking. Maintaining 1800 volts constant during motoring is the function of line converter, but in braking, that is the function of traction converter. So that 1800 volts DC supply comes back to this, and even it goes to auxiliary converter also. And the same supply comes to this line converter. Then line converter converts this 1800 volts DC into single phase AC by monitoring continuously the OHE voltage. Continuously line converter measures the OHE voltage and it generates or converts the DC into single phase AC such that in traction transformer primary, it generates more than the OHE voltage. So like that, the line converter works and convert that DC 1800 volts DC into single phase AC. The same will be given to traction transformer secondary. During braking, this traction transformer acts as a step-up transformer and converts that into this 25 kV supply, and continuously system measures the OHE voltage and little higher voltage will be generated in primary. So that obviously current starts flowing from higher potential to lower potential. In this fashion, the current will be fed back to the OHE. That is, we'll call it as, this phenomenon we'll call it as regenerative braking. Regenerative braking. Okay. So during braking, this is the flow from traction motor to auxiliary converter, and as well as the same supply goes to OHE supply. Reverse from train, the supply will be fed back to the current will be fed back to the OHE line. That is called regenerative function. So is it clear? This is what about power scheme in MEMU, of course, as well as same in EMU also. Right? If it is clear, I'll move to next. Fine. Next, operation details. When it comes to this MEMU operational details point of view, here each basic unit contains 4 coaches. जैसे हमने discuss किया है, हर एक basic unit में 4 coaches रहेंगे. And the train formation can be formed either 2 basic units, 3 basic units, or 4 basic units, 8 coach, 12 coach, or 16 coach formation. And this can work up to maximum 110 kmph. This is service speed. Service speed जो है 110 kmph, maximum 110 kmph तक it can go. And the test speed is 120. In general, more 10% will be tested during trials. So test speed is 120. And OHE line voltage, in general, nominal supply, we'll call it as 25 kV single phase 50 Hz supply. But as per the specification, RDSO specification, this should work between 16 to 30 kV. 16 kV to 30 kV, the system should work, and below 16 kV or above that, it should cut off to provide the safety to the entire equipment, right? That is about OHE variations, and frequency point of view, it is 50 plus or minus 4 Hz. So 46 to 54 Hz, the system can work normally as per RDSO specification points. And next, when it comes to major equipment layout, where exactly the equipment placed in MEMU, latest MEMUs, 3-phase MEMUs, if we see, major equipment is placed only in DMC coach. So DMC coach side view, top view, and bottom view, underslung view. Side view, if you see here in the initial, this is the driver cabin with the cab AC unit. And in this driver desk is there from MEDHA. And just back to this, the CRW panel is there. That is also from MEDHA. And cab AC unit, to 2-ton rating AC unit, we are taking from outside like Prague, Koolair, Subros. These are all the makes of driver cab AC unit, which works on 415 volts 3-phase AC supply output of auxiliary converter. And just back to this driver cabin, this entire place unit is called HT compartment, high tension compartment. This high tension compartment is equipped with LTC and aux converter and baby compressor. CRW panel is there in the like towards driver cabin side. And roof here, if you see, this is what the equipment on the roof we can find as usual, like pantograph, then surge arresters, HVPT, VCB, AC earthing switch, and HT cable, and a brake chopper resistor. So during over voltages, this resistor is placed on the top. Actually, it is a single unit, but internally there are 2 resistive elements, each 3.4 ohms in 2 parallel path. So basically this resistor unit is natural cooled because as it is for short term rating, hardly in the order of milliseconds. So this is what the equipment on roof. Out of all this, only brake chopper resistor is from MEDHA make. Remaining all are from outside. And just back to the HT compartment, this remaining entire portion is passenger saloon area. Right, almost it is like 40-60, 35-7-65 ratio in DMC coach. And in this passenger saloon area, lights, fans, and PIS, passenger information system, speakers and LED boards, then CCTV surveillance system, all these equipment placed in the passenger saloon area. And when it comes to underslung, as it is Bobo configuration, lead bogie and trailing bogie, both are equipped with two traction motors. And here we can find traction motor 1, 2, 3, and 4. In each bogie, for balancing point of view, both the traction motors are provided in opposite direction to each other for balancing. So from line and traction converter 1 supply will be given to these two traction motors. As these two motors are physically placed reverse to each other, TM2 and TM4 electrical supply also we have given in reverse so that all the motors can rotate in same direction. So during maintenance, ye yaad mein rakhna hai ki how you are opening the connection, the similar way again exactly you have to connect. Okay, because we have given connection to this motor UVW and here one phase is swapped for number 2 and number 4 motors as they are physically placed reverse to number 1 and 3 motors. That is what the reason electrical supply also given in reverse, right? And when it comes to middle part here, this is traction transformer, 1250 kVA rating, oil cooled transformer from ABB or Siemens. And all other auxiliary reservoirs, main reservoirs, and main air compressor. Main air compressor is from Favely, Norbrims. Okay. And after this battery box, 96 volts, 120 AH battery box, and one EP brake unit. So these are all the equipment in underslung, right? So this is side and top view, and there is bottom view on DMC coach. And front view, if you see, here we can find this is a CRW panel, cab rear wall panel, just back to the driver. This is purely from MEDHA. This is the main unit to control train level. Inside this control electronics part is there, which collects the driver commands and share the data with all the coaches in train. And this side, it is driver cab AC unit, 2-ton rating from Prague, Cool Air, Subros. And this provides the cool air in driver cabin. And just about to that, this DC earthing switch and here AC earthing switch, headlight converter, these are all we can find. And from side view, if we see, just back to the driver cabin, this is the HT compartment. Here, this one is auxiliary converter and this side traction converter. So same from top view, we can find here the bigger unit, this one. When we enter into HT compartment, right side bigger unit is LTC, 1300 kVA line and traction converter, air cooled converter. And left side 120 kVA rating auxiliary converter unit. Both are from MEDHA. And here there is a small compressor, auxiliary air compressor or baby compressor to provide the pneumatic supply to the pantograph. Okay, as Panto is electro-pneumatic device, it requires both electrical and pneumatic supply. In the initial, electrical supply comes from battery bank. Pneumatic supply will be provided by this auxiliary air compressor. You know very well, a baby compressor or auxiliary air compressor, which works on 110 volts DC supply, right? So this is the equipment layout. And locations point of view, both means DMC and TC coaches. If you see this driving motor coach and the trailer coach. In general, three sections like onboard, underslung and roof equipment in DMC coach. Similar way, TC coach, trailer coach. First, if we discuss about DMC onboard equipment, this driver desk, DMC ECC or CRW panel, line and traction converter, auxiliary converter, auxiliary compressor, DC earthing switch. These are all placed on board. Out of all this, except this auxiliary compressor, remaining all from MEDHA, we are providing. DC earthing switch, of course, we are taking from outside, but remaining driver desk, DMC ECC, line and traction converter and auxiliary converter, these are all from MEDHA. We are manufacturing. Next, underslung point of view in DMC coach, traction transformer, traction motor, main air compressor, battery box with battery, then parking brake. Here in MEMU, in all DMC coaches, only in DMC coaches, parking brake mechanism is provided as per our DSO and ICF for 1357 wheels. And EP brake unit, as usual, common for all the coaches, this EP brake unit. Out of all this, MEDHA make is this traction motors, remaining are taking from outside. And when it comes to DMC roof, pantograph, VCB, brake chopper, HVPT, surge arresters, and AC earthing switch. Again, out of all this, brake chopper is MEDHA make, remaining all taking from outside. So this is about DMC coach, onboard, underslung, and roof equipment. Next, when it comes to trailer coach, in each and every trailer coach, two end wall panels are there on board. When we stand in line with the coach, front left side and back right side, both sides diagonally, front left and back right, end wall panels per coach, two end wall panels, end wall panel 1 and end wall panel 2. Two end wall panels placed in one coach. One end wall panel is provided with coach electronics, computer and relays contactors. The other end wall panel is provided with PIS, car control unit, CCTV, NVR, so related circuit. Okay, next we'll see that photographs. This onboard point of view, only two end wall panels in all trailer coaches. And when it comes to underslung trailer coach, underslung, as usual, it is common EP brake. Each and every coach is provided with one EP brake unit. Okay. So this is the equipment location in MEMU formation. Right. So next, scope of supply. Scope of supply point of view, here IGBT based line and traction converter. As it is bogie control, each converter drives two traction motors. And this IGBT based air cooled line and traction converter is from purely MEDHA, 1300 kVA rating. And auxiliary converter, 120 kVA rating. It generates three low voltage signals, 415 volts 3-phase 58 supply, 110 volts single phase AC supply, and 110 volts DC supply from the input, 1800 volts DC link supply. And this is also purely from MEDHA, and this is also air cooled converter. There is a blower which works on 415 supply to cool the auxiliary converter. Next, TCMS. All the coaches is provided with this coach electronics. So train control and management system is purely again from MEDHA, Ethernet based communication system. All the coaches are provided with passenger comfort computers, and they are all connected via this Ethernet based communication. And input commands will be received from master controller by these computers, and it will share with all the coaches, coach electronics, so that in individual coaches, the same functions will be executed as per the driver command. And the same data will be fed back to the lead DMC computers for recording, indication, and remote monitoring purpose. Next, this air supply. Air supply, as I said, it will take from outside like compressor, filter, dryer. So in general, NORBEMs are Favli or Elgi. So Favli make more compressors are there. Next, traction motors from our company, MTEPL, joint venture company. So we produce traction motors here, asynchronous or induction motors for each DMC 4 mode numbers. Next, this complete driver desk along with a display unit, gauges, switches, lamps and all, including master controller. So this DDU is 10.4-inch LCD TFT screen, liquid crystal display with a thin film transistor technology. It is taken from our MEDHA make, and master controller is taken from outside, that is from Shalbo. Shalbo make master controller we are using in the driver desk. And passenger information system, PIS, this is purely again from MEDHA. As per railways requirement, this automatic audio visual announcements purpose, we are providing this passenger information system. Before starting the train journey, if we configure the route, automatic announcement will take place based on the GPS location. Next, control panels in DMC and TC with contactors relays. In DMC coach, CRW panel, and in all other trailer coaches, end wall panel 1 and 2. All these end wall panels, control panels provided with all coach electronics, computers, relays, contactors, breakers, firing, everything our MEDHA makes supply. Next, load weighing system and parking brake. Load weighing system. Each and every coach is provided with 4 air suspension bellows. So air suspension bellow pressure is being mounted by MEDHA system, and based on the pressure value, system applies the brake. Okay, and in case of that air suspension bellow, health also will be monitored by system. In case of any leakages or puncture, it declares the fault with appropriate speed limitation. Next, parking brake. In DMC coach for 1357 wheel sets, provided this parking brake by railways. The control system is provided with MEDHA. There are 2 switches in the desk, apply parking brake, release parking brake. So when we are going to be in standstill condition for longer time, at that time we need to apply parking brake manually. And before starting the train, compulsory we have to release first brake and then can work the train further. So that parking brake control system is there with TCMS. Next, cables. So cables and IV couplers, intervehicular couplers and cables. IV couplers means coach to coach and cables means within the coach. So all these cables are taken from the RDSO approved vendors like Radiant, Huber-Suhner, Leone, Seicham. So these are all the Amphenol, Harting. So these are all makes of RDSO approved vendors. Next, VCB, vacuum circuit breaker, is taken from Autometer or Schneider. Then Pantograph is taken from Schenck or Favli. Then traction transformer is from ABB or Siemens. All lights, interior and exterior lights. Then CCTV, surveillance point of view. The CCTV system is from MEDHA. So far, these are all the equipment. And after that, ICF scope of supply is complete pneumatic brake and battery box with a battery bank. These are from ICF. Main air compressor and dryer filter and battery box with bank. These are from ICF. Remaining all are from MEDHA. So this is about scope of supply, what we are using in MEMU, 3-phase MEMU trains. Okay. So any point at any time, you can ask anyone. Right. If it is clear, then I'll move to next. Next is end wall panels. End wall panels are placed in a train in all the coaches like. So here in trailer coaches, when it comes to this DMC coach is provided with CRW panel, and here opposite alarm end side, end wall panel 1, end wall panel 2. these are only like junction boxes to forward the electrical signals from this coach to next coach and DMC coach. But next, when it comes to all the trailer coaches, here left side, non-alarmment side left and alarmment side right. Two end wall panels are provided, end wall panel 1 and end wall panel 2. Okay, in each coach, the similar way provided. And all these end wall panels, CRW panels are from MEDHA. Okay. Next, when it comes to control electronics part, so far we have discussed about basic unit, rake, and major subassemblies, their location. About power scheme we have discussed and scope of supply discussed. Next, when it comes to control electronics part, how the control system controls entire train, TCMS, train control and management system, how it controls the entire train. If you see, this is the power scheme, control scheme architecture. So here each basic unit wise, we have taken one BU, DMC, trailer coach 1, 2, 3. Total 4 coaches. DMC 1 is provided with all these computers with Ethernet based communication. So one by one we'll discuss all. Here this driver desk, the driver sitting at driver desk operates the handles as per the requirement. All these commands will be given to this MCU1, MCU2, main control unit 1 and 2, which are placed inside the CRW panel. These two are main for basic unit control and as well as to send the data to other basic units. So these driver desk commands will be given to MCU1 and 2, and MCU1 and 2 upload the data to ECN switches. Immediately these ECN switches transmit the data to other coaches, and via these ETB switches, this will be shared with other basic units. ECN, Ethernet Consist Network switches are for only basic unit level communication, and ETB switches are for overall rake level communication, right? So when main control unit MCU 1 and 2 receives the information from the driver desk, it gives the commands to LTC, line and traction converter, for converting single phase AC into 3-phase AC and giving the supply to motors. And the same information will be given to other, like here there is a RIO computer, remote input output computer inside the CRW panel. That is for passenger comfort functions like coach lights control, fans control, brake control. All these controls will be done by this RIO. Even circuit breakers, feedback monitoring and all done by this RIO computer. And the same RIO is only connected with this PIS, passenger information system, and it shared the data to the PIS system. And next there is a auxiliary computer unit inside the aux converter. And this auxiliary computer unit, as per the MCU 1 and 2 commands, it controls the aux converter such that it converts 1800 volts DC into 3 low voltage signals. And here there is a RMS, a remote monitoring system. All the 8 coaches data will be collected by this MCU 1 and 2 and share the data to this RMS, remote monitoring system. Inside that, there are 2 GSM chipsets and 1 GPS. GSM chipsets, whenever signal available, it share the data to server. So remotely, globally, any person through internet connection with valid credentials can connect to server and can download the data for further analysis. That is about this remote monitoring system. Okay. And next here, there is a speedometer in the driver desk, speed recorder. This is also connected with MCU 1 and 2 via RS485 communication for data exchange. And there is a FGU, frequency generator unit inside the driver desk. Here, train controls point of view, if communication is healthy, train works in normal mode. And in case of any problem in communication, automatically train works in special RDM mode by taking the signal from the FGU. FGU gets the commands from master controller. That current signal converts back into frequency signal and share the same frequency with to all the computers in the train. So in case of communication failure, tractive effort and braking effort will be calculated by using this FGO signal. So that mode we call it as special RDM mode. From normal to special RDM mode, it is automatic changeover in case communication failure. And further, if train is working with FGO and even FGO also faulty, then automatically train comes to standstill position and throttle will not respond with the TCN failure lamp. In special RDM also, TCN failure lamp glows. But if TCN failure lamp glowing, but still throttle is responding, means train is working in special RDM mode. But further, if TCN failure lamp is glowing and throttle is not responding, means FGO also faulty. There we need to manually change over from special RDM to RDM mode. In master controller, that key on switch need to change from on to RDM position and can work the train further with limited speed. Here the limited speed in general it is at 55 kmph in MEMU. Okay, that is about operating modes, normal, special RDM and RDM modes. So this is about all the architecture in DMC coach. And further when it comes to this via ECN switches, this data will be received to these trailer coaches. In trailer coaches only PCU computer is there, passenger comfort unit computer, which controls the passenger comfort functions like lights control, fans control, EP brake control, air suspension bellow control. So all these functions will be done by this passenger comfort unit, right? And here ECN switches even upload the data to ETB for rake level data exchange. ECN switches are for only basic unit level exchange, but ETB is for entire train level communication. So in all the coaches, same ETB, ECN switches, passenger comfort units are provided in all the other trailer coaches. So this is about architecture, how exactly control electronic works in three-phase MEMUs. Is it clear? Okay. Now any doubt? I'll move to next. The same individual computers, what we have discussed in this architecture. Out of that, major computers are like MCU 1 and 2, then DMC, RIO and PCU computers. One by one, if we discuss MCU, there are, as it is an important computer to get the 100% redundancy, MCUs are provided 2 numbers in CRW panel, MCU1, MCU2. By default, MCU1 is the master until unless it is healthy. In case any problem, automatically it will switch over to MCU2 with appropriate message. And MCU consists of one control card, MOMC, 4 digital input cards, 3 digital output cards, 1 analog input frequency input card, and 1 power supply card. This control card is major controlling equipment provided with controllers and logics, and digital input cards to receive the digital signals from train, digital output cards to drive the contactors, relays, solenoids, lamps in the locomotive or train, and analog input frequency input card to process the sensor signals, analog sensors and frequency sensor signals to computer readable language. And power supply card function is to convert 110 volts DC into low voltage signals, which are required for the operation of all other cards in the computer, right? And MOMC controls total basic unit level and as well as entire train level. Next, it shares the data to train level. And MOMC communicates with all other computers in the basic unit like LTC, aux computer, speed recorder, RIO computer, PCU computers, and with other basic unit MCUs. So this is about MCU 1 and 2, both are same. And RIO computer, this is also like almost same hardware, only software logics will get changed. 1 control card, 3 digital input card, 2 digital output card, 1 analog input frequency input card, and 1 power supply card. Based on the requirement, we provide this number of cards, hardware. And the main purpose of this RIO computer is to read all MCB's feedback, main circuit breakers feedbacks, whether the breaker is in on condition or off or triple condition. And additionally, passenger comfort controls and coach brake control. passenger comfort control means light control, fan control, and then coach brake control. And adjacent coach passenger comfort control. In case adjacent coach PCU failed, this RIO computer can control adjacent coach passenger comforts and brake control through train lines. Similarly, PCU passenger comfort unit, only the nomenclature is different. In DMC coach, we call it as DMC RIO. In all other coaches, we call this as PCU passenger comfort unit. The same hardware, again, one control card, one digital input card, two digital output card, one analog input frequency input card, and one power supply card. Only software logics are differed from other computers. And the main purpose of this passenger comfort control also, it is for passenger comfort controls and coach brake control of self coach and as well as adjacent coach passenger comfort. In case of failure in DMC coach passenger comfort unit, then this adjacent coach Taylor coach can provide the supply to DMC coach passenger comforts and brake controls via train line signals. So these are all the functions of major computers which are placed in MEMU control system, part of TCMS. So major functional features when it comes to MEMU functionality point of view, what are all the major functional features with the three-phase MEMU control system? If we see modes of operation, already we have discussed. In general, if entire communication is healthy, train works in normal mode. And in case communication is declared as faulty, automatically it will switch over to FGU via frequency generator unit signal. Train works in special RDM mode without any limitation, without any speed limitation. As usual, up to 100 and 110 kmph train can run. And this is automatic changeover from normal to special RDM mode in case this communication failure. But even further, FG also fails from special RDM to RDM is manual intervention is required. There is no automatic changeover. So manually we have to change over the key on switch from on to RDM and can work the train with limited restricted speed. That is up to 55. That is about normal modes of operation. Next, pantograph control. TCMS controls the panto switch commands. It receives the same commands and controls the panto. Similarly, VCB control. Then lamp test during maintenance or during online. If you want to check the functionality of all the lamps in the driver desk, we can press the lamp test button and can ensure the functionality. The neutral section. This is wherever that changeover from substation to substation or phase to phase, there is a section called neutral section. Before neutral section, a board is there, signboard, 250 meter signboard. Here in MEMU, three-phase MEMUs, as an operator, we have to press only this neutral section switch, 250 meter signboard. Automatically remaining everything will be calculated by system and one by one VCB will get open and after crossing the neutral section, it close the VCB for normal operation. So only once we have to press the neutral section switch, that is called ENS, expected neutral section switch. In driver desk in front of the driver, that ENS is provided. So at 250 meter signboard, we need to press once ENS switch so that automatically entire remaining calculations will be done by TCMS. And EP brake control. So when we apply the brake, system controls this EP brake. Inside the EPBU, there are two valves, application valve and holding valve. Both the coils of supply will be controlled by system by measuring the air suspension bellows feedback. Based on that, the EP brake system will be applied by the system. Then cruise control.
Yes, sir.
Yes, sir.
Yes, sir. Again, after passing neutral section, we have again press ENS switch.
No, sir.
No, sir.
Once.
Okay, once.
It is not required.
It is not required.
250 meter
250 meter signboard.
Yes. Sir, please keep in
mute, sir.
Only whenever before neutral section at 250-meter signboard, we need to press ENS only once. After crossing the neutral section, whenever OHE re-established, then system automatically close the VCB and it exit from the neutral section logic. Only for entry, we need to press once, right? But when it comes to cruise, it is clear, sir?
Yes, sir. Yes.
Okay. The neutral section, that is
Rajesh.
only once we need to press. And when it comes to cruise, neutral.
Rajesh. Hello.
Hello.
Rajesh, this is CND
Yeah.
Avadi.
Sir.
Here actually, if we press that ENS,
Sir.
just before the neutral section, we are telling a 250 meters warning board. We have to do this one, right?
Yes, sir.
If we do at 20 meters before the neutral section, then how the logic will be?
Actually, sir, instead of 250 meters, as you were saying that key within that 50 or 100 meters, in general, there is a logic here. We have given that key whenever OHE cuts off, goes out of range, 16 or above 30, immediately system opens the VCB and it starts the neutral section logic. Okay. In general, it should not be a standard practice. We should operate at 250, but other than that also, if operate at 100 meters or 200 meters, soon after immediately loss of that OHE supply, system automatically starts the neutral section logic, and after again OHE establishment, system close the VCB of first DMC. And the same logic will be continued for other DMCs which are placed in the rake, same rake. Okay. Automatically it will enter into neutral section logic. That is one case. And another case is that where the neutral section is not available, but still operator accidentally or unknowingly press the ENS switch. Let us. So after 250 meters, system opens the VCB, but it monitors continuously OHE voltage. If the OHE voltage is available continuously, then after 500 meters, it will exit from the neutral section logic, as it is matlab wrong operation, wrong command. Clear, sir? Point?
Yeah, it means that for 250 meters, it will be waiting for the neutral section to encounter, right?
Yes, exactly, sir. Exactly.
So beyond 250 meters, it may not be sure that it means the 500 meters before. Actually, there is a 500 meters warning board also.
Yes.
So if anybody presses at 500 meters, then I think it will come out of this neutral section logic before the neutral section is encountered.
No. If, for example, if we press at 500 meters, after 250 meters only, it will open the VCB and wait for more 500 meters. It is not within that 500.
Means at 500 meters also, you can press it and you can wait, right?
No, sir. As you are saying, like if, for example, there is a signboard at 250 meters and 500 meters, right?
Yeah.
In general, we should press at 250 meters, but instead of that, if someone pressed at 500 meters only, let us. So from that point, after crossing 250 meters, system opens the VCB and wait for more 500 meters. Yani, during that time, after crossing 250 meters more, it comes into neutral section, and as it is, system continues the same logic because there is a loss of OHE voltage. Whenever again re-establish after crossing the neutral section, system ensure that OHE voltage and it allows for more 80 meters and then it close the VCB for that DMC. Clear, sir?
Is it possible to map it with the GPS? Automatic as well as manual we can implement now, sir.
We
Signaling,
can,
fog signaling already mapped. Like that, 250 meters also we can map it, and in high speed, for example, 160 km/h and all, it will be very useful.
Yes, exactly, sir. We can do based on the requirements, sir. So many things are nowadays, TICAs and all further implementing lot of system controls. So based on the requirement, even we can go for this also. But as of now, it is manual. Okay, sir. Okay. Right. So next, after this cruise control is for to run the train at constant speed, right? So for example, train attains at almost 100 kmph, for example, and it needs to run at 100 only. So then we should press the cruise control switch so that the same speed will be maintained by the system. And for neutral section, only once it is required. Exit is automatic, but cruise control point of view, exit, we need to give the command. So when we should come out from the neutral section, bring the throttle to coast once, so that automatically it will come out from the neutral section, cruise control, and the speed will be controlled based on the throttle signal. Is it clear? Neutral section logic, only once we need to give the command in entry command. Exit is automatic. But when it comes to cruise control, keep the deadman handle and wait till the required speed to achieve, and then press the cruise control switch so that it enters into cruise control mode. It maintains the constant speed. And when we wish to exit from the cruise control, bring the throttle to coast once, so that automatically it will come out from the cruise control. Okay. Next, BU isolation, basic unit isolation. Here, in case of any requirement or shunting, during shunting purpose, we can isolate total basic unit and we can work with only single basic unit. Load weighing system. Load weighing system already we have discussed. Each coach is provided with 4 air suspension bellows. System monitors or bellows pressure continuously, and based on the calculation, it applies the brake, EP brake to the individual coaches, if it is normal load or dense crush load like. And even in case of any air suspension bellow faulty also, the same will be detected by system, and it restrict the train speed to 60 kmph or 55, whatever the configured value. Next, auxiliary air compressor control. Soon after power on the train, system starts the auxiliary air compressor to run and maintain the pressure for the pantograph to raise. And then compressor management. Compressor pressure, MR pressure, will be continuously monitored by system, and as per the set value between 6 to 7 bar, continuously system monitors and controls accordingly the main air compressors. Cut in, cut out. And parking brake control in DMC. Only in DMC coaches this parking brake mechanism is provided. So parking brake control also will be done by based on the switch commands. Apply parking brake, release parking brake. Based on that system, apply the brake and release the brake. Then switch off at under voltage protection. Continuously system measures the battery normal supply, battery supply, and because of any reason, if battery is not charging and the battery normal supply voltage goes below 86 volts, immediately system gives the message and cuts off the traction. It is switch off at under voltage protection, right? And to clear the section, there is a bypass switch. We can switch on that and bypass that feature, under voltage protection, and we can clear the section. It is only for clearing the section, not for continuous operation. Next, emergency off loops, emergency brake loop, brake applied loop. These are all different safety loops provided in the train for normal operation. During normal operation, all these loops should be in closed condition. Okay. If any loop goes out of range, out of emergency off loops, there are 3 loops, 2 out of 3 logic. In emergency brake loop also 3 loops, 2 out of 3 logic should satisfy. And brake applied loop also should satisfy. Other than this, any abnormality, then system cuts off the traction and provide the safety. And single unit operation. In shed level, if we want to move only one single basic unit, physically only 4 coaches, then we can go for this single unit operation mode. And there, without this loops, system ignore that loops and can allow the speed up to rated that configured value. In single unit operation, the speed will be restricted and we can work the train in shunting for mainly shunting purposes. Then Deadman Protection. In throttle handle or master control handle, there is a deadman switch. Always operator has to hold that. If he released the deadman handle in other than post, system applies the brake to provide the safety. And signal bell, there is a signal bell.
Rajesh sir.
Sir.
Yeah. Emergency off loop 2x3 logic here.
Yes.
That means in 3 loop will be there. Minimum 2 is there means train will work.
Yes, sir. Yes, sir. Exactly. 2 out of 3 logic means there are 3 loops in emergency off loop, EOL or EBL. There are 3 loops, 2 hardware loop and 1 software loop. Total 3.
Okay.
For out of 3 loops, any 2 loops should be in okay condition. Then system thinks that this is okay. Right? 2 out of 3 logic means out of 3 loops, 2 loops should say okay.
Right.
And signal bell, it is we know very well for communication. So these are all the functions. And further, this passenger alarm, chain pull system, only indication will come. The audio visual alarm while crossing the caution signals by the driver gives the indication to guard. And passenger lights control, passenger fans control, exterior lights control. Okay. And change your contactors for 110 volts AC and 415 volts AC. These are redundancy cases. Like, for example, 8-car formation we are working, and each basic unit is provided with one auxiliary converter. That auxiliary converter provides a supply 110 volts AC, 415 volts AC to all the 4 coaches. In case while working the train, out of 2 basic units, 1 basic unit aux converter is faulty. Then automatically system pick up the changeover contactors, and adjacent basic unit aux converter provide the supply to self basic unit as well as the faulty aux converter basic unit also.
Rajesh sir.
Yes.
You have told single unit operation, no sir?
Yeah.
How to go that single unit operation and what is the speed?
Actually, sir, single unit operation in CRW panel, there is a switch.
Yeah.
Single unit operation. Basically, always in general, we move the train as a 8-car formation minimum. But in shed level, during IOH or POH, if we wish to move only 4 coaches, 1 basic unit, that is single unit. Okay. In general, if we detach the train, all the EOL loops, EBL loops, BAL loops will get open. Cab occupied loop, everything. But intentionally, we wish to move now only 1 basic unit. So at that time, if we select that single unit operation, system ignores that loops and with limited speed, it allows the traction. That is for purposes. Sir. Clear, sir?
Sound not clear, sir. What is the speed, sir?
Sound not clear. It is for shunting purposes, sir. It is not open line operation. When we wish to move 1 basic unit in shed level during maintenance or IOH, POH, if we wish to move 1 basic unit in shed level, all the basic units will get open now. So at that time, in general, system won't allow for traction. So to bypass that, this single unit operation selection, if we do select the single unit operation switch, system ignores all the safety loops and it allows for shunting purposes up to that limited speed, 15 kmph or set value. Okay. Right. And test modes, there are different test modes we can conduct during maintenance. System ensures conduct all the tests and finally it gives the results whether the particular functionality is okay or not. So these are all the functional features by TCMS. Okay. Next, there are different type of sensors in train for different applications. Here there are current sensor, voltage, speed, temperature sensors. As per the application, we have provided different sensors in different places. Continuously, TCMS monitors all these sensors feedback, and based on those values, self-diagnosis system is there. System provides the safety, and if everything is okay, all the information will be recorded, indicated, and works the train normally. In case of any abnormality, as per the software logic, system declares appropriate fault message and it provides the restrictions. Right. So for that purpose, these all the sensors feedbacks will be monitored by the system continuously. Next, driver desk. So here driver desk in two directions we have taken the photograph, divided into driver console area and this guard console area. So everyone I think knows very well for driving the train and guard functions and passenger comfort controls. And in front of driver, there is a driver display unit in driver desk. It is 10.4-inch LCD TFT screen. All the information, train information, parameters, status icons, everything we can find on this DDU. Okay, this is also from MEDHA. During normal operation, we can find like this. So this is rake level by default screen with the 8-car formation. And if we wish to see only one single basic unit, individual coach level, then if we tap on this and individual DMC, TC 1, 2, 3 like that, we can find all the information we can find on the screen. In general, all these status icons should be for normal operation, all should be white, gray or blue in normal. There should not be any black, yellow, red that indicates some faults. And pink is normal brake applied condition. Okay, there should not be any yellow, black, red. We have taken this on simulator, so ignore. We can ignore this. But in real time in display, there should not be any yellow, black, red. They indicate some limitations. Always normally blue, white, and gray should be there with pink brake applied condition. Then FGU we have discussed to get the advantage of special RDM mode. While communication declared as faulty, system automatically change over to this FGU signal to get the advantage of special RDM mode. In special RDM mode, there is no any restriction. Up to 110 kmph, the train can work normally without any limitation. Next, CRW panel, crew rear wall panel or cab rear wall panel. This panel is from MEDHA and it is placed in each DMC coach just back to the driver seat. This is part of HT compartment facing towards a driver cabin. Okay, a closed photograph and in open view we can find like this. So in closed condition only switch panel and breakers panel we can see. We can access switch panel and remaining everything will be in locked condition. And if you open the doors, we can find internally like this all MCU1, MCU2 computers, RIO computer, remote monitoring system computer, remaining all breakers, switches, Ethernet switches, contactors, everything is placed inside this CRW panel. It is important for entire TCMS to control individual basic unit level and as well as for train level controls. All the main important computers are placed inside this unit. Okay. And this is purely from MEDHA CRW panel. And next, when it comes to line and traction converter, which is placed in the HT compartment of each DMC coach, this single unit is line and traction converter, air cooled line and traction converter, IGBT based, 1300 kVA rating, is purely MEDHA make. This converter contains 4 converters inside, IGBT based converters, 2 line converters and 2 traction converters. For each bogie, 2 traction motors, 1 line and traction converter. Okay. The air will be sucked from here and the opposite side 2 blowers are there. So whenever the air is sucking by this from here, here phase modules are provided. Heat sinks are placed in the passage. So that collects the heat and the hot air will be exhausted to the underframe, underslang. So it is LTC line and traction converters. Inside that there is a control unit inside the line and traction converter. That control unit is further divided into 4 parts, 4 computers. For each converter, 1 computer, 2 line converter computers and 2 traction converter computers. The function of line inverter computer is to convert single phase AC into DC with unity power factor at input side. That is the line inverter computer function. And the traction inverter computer function is to control or convert DC into three phase AC, that to bogie control. Either tractive effort or braking effort will be controlled bogie wise during motoring or braking, both sides. That is the function of traction inverter control computer. And all these computers communicate among themselves and get the input commands from MCU via Ethernet based communication. And finally, all the data will be shared to MCU for recording, indication and closed loop control functionality. So that is about LTC. Next, auxiliary converter unit. This auxiliary converter unit is again air cooled converter, which is physically placed in HT compartment. When we enter left side, it is placed in left side. So there is a filter. From here, inside blower sucks the air and the hot air will be exhausted through these bottom vents to the underslang. And this auxiliary converter input receives takes from DC link 1800 volts DC. And inside this, there are different sections to generate 415 volts 3-phase 50 Hz supply, 110 volts single phase AC supply and 110 volts DC supply. All those three outputs will be given to individual basic unit for normal operation. This is 120 kVA rating converter. If all the auxiliary converters in individual basic units healthy, then changeover contactors will be in open state. So each auxiliary converter provides the supply to these three low voltage supplies to only 4 coaches. And normally it works. But while working the train, redundancy concept is provided via that 110 volts changeover contactors and 415 volts changeover contactors. In case this aux converter is declared as faulty in a basic unit, the adjacent basic unit aux converter supply comes to this basic unit. For that purpose, internal changeover contactors will be energized by the TCMS automatic system. Since this fault status of this aux converter and system energize the changeover contactors in between two basic units and get the auxiliary supply from the adjacent basic unit. So 100% loads will work normally because all these auxiliary converters as per RDSO designed for 200%. For normal operation only 50% loading. Each converter is loaded up to 50% only, but it can provide supply for two basic units. Okay. So this is about auxiliary converter. This is also purely MEDHA make air cooled converter. Next, traction transformer. This traction transformer is our scope of supply, but we are not manufacturing. We are taking it from outside, ABB Siemens. In MEMU, in general, ABB and Siemens make oil cooled 1250 kVA rating traction transformers is being placed. So with a radiator mechanism to cool the oil. And there is a oil pump and cooling blowers with all these facilities provided this traction transformer. And the main function of this traction transformer is to step down the OHE voltage 25 kV into 950 volts. This transformer is placed with the 2 secondary windings. One primary winding which is connected with OHE supply and the 2 secondary windings output will be given to LTC. Each secondary winding output is given to one LTC line and traction converter. Okay, so this is about traction transformer. In MEMUs in general taken from ABB and Siemens make. And this traction transformer during motor it acts as step down transformer, but during braking this works as step up transformer. Okay. And next,
how supply is brought from roof to underslang, sir?
Sir?
How the 25 kV is brought from roof to underslang?
That is through HT cable, sir. There is a HT cable. After that Panto VCB through surge arresters, the supply HT cable comes to, via HT compartment to bottom. There is a HT cable passing from top to bottom via HT compartment. Okay. Is it clear, sir?
Yes, sir. Okay, sir.
HT cable is passing from roof to underslung via HT compartment only. Next, traction motors. These are asynchronous or induction motors. Squirrel cage, asynchronous or induction motors. This technology is actually we have taken from traction system Astria under joint venture. Production unit is here only in Hyderabad. So we are manufacturing these traction motors. Not only motors, we'll supply motor, gearbox assembly and MSU, main suspension unit as a set. Only axle is from railways, axle and wheel set. So these traction motors are self-ventilated motors. There is no requirement of any external cooling blowers. Whenever traction motor is rotating on the rotor shaft itself, there is a mechanical fan that acts as a suction blower. From the non-drive end, it sucks the cool air, and from the drive end, through this vent grates, the hot air will be exhausted. Because of that, we'll call it as a self-ventilated motor. And these are 268 kilowatts continuous rating power. And in general, for normal operation, we need to check the oil level. Okay. And in case oil level is below minimum, we need to top up in regular. Otherwise, yearly once we need to replace the complete oil, and we need to top up the grease for traction motor. Both ends, bearings are there, drive end and non-drive end, that side, and even MSU should be top up with grease, and only gearbox assembly need to replace the complete oil yearly once. And major schedule is for 6 yearly once. Till 6 years, there is no any major attention required in traction motor, only topping up and replacement, oil replacement yearly once. Okay.
Excuse me, sir.
Sir.
Sir, the oil top up yearly once, or there is a kilometer?
No, sir. Top up is every schedule we need to check, and if the oil level is below to this minimum level, there is a
During, yes, sir, we are top up, sir. When you have to replace?
Replace is for yearly once. In general, yearly once are 1,80,000 kilometers. As per the OEM, 1,80,000 kilometers are yearly once, whichever comes first. Clearly defined in the manuals, sir. Traction motor manual.
Yes, it is mentioned.
Yes, yes. Whichever comes first. Whichever first, that we need.
Thank you, sir.
Right? Okay. So this is about motor, and here the rating, nominal power, voltage, current, frequency, and all it is given. Asynchronous or induction motor. Right? Next, this surveillance point of view. Nowadays, in all the trains, this CCTV system is being provided by manufacturers. So here from Hikvision, so far we have taken from Hikvision. In all the coaches, 4 cameras are provided with one NVR, network video recorder. So latest 1 month backup we can find. All the cameras dump the data into this NVR. Inside that there is a hard disk, 2 TB rating, 2 terabytes hard disk. And this hard disk continuously, if all the 8 cameras, for each NVR, 8 cameras we can connect maximum. If all the 8 cameras are dumping the data into NVR, latest 1 month backup we can find. After that, it is first in, first out. Okay. Only latest 1 month backup we can find. Over and above data will get erased. Latest 1 month data will be available. This is NVR. Inside that hard disk in locked condition, and cameras. Next, speed time distance recorder. The speed recorder MRT 918. It is placed in the driver desk in front of the driver. While working the train, in case because of any issue, if driver display unit got defective or it is not showing, it is blank, still the train can be worked by seeing this speed recorder. So for that purpose, it is provided recorder cum indicator unit, junction box, and speed sensor. The speed sensor placed in the first axle, DMC coach, first axle left side. From there, the signal comes via this junction box to speed recorder cum indicator unit. So internally it records and it shares the data with the TCMS, and even it indicates the speed on the speedometer. Okay, this is MRT 918 type. Next, finally, passenger information system, PIS. So this PIS is for automatic audio visual announcements. Automatic audio visual announcements, passenger information system. So generally, before starting the train journey, guard, it is in general guard responsibility. Guard has to configure the train route by using this MMI, man machine interface unit. It is placed in the driver desk. All the route files, maximum 250 route files can be uploaded into the system. So with the train number only will upload as per railways requirement. So before starting the train journey, driver has to configure the train number so that this MMI share the data to all the individual coaches. In each and every coach, there is a car control unit. This car control unit acts as the local master for each and every coach level, right? So this car control is connected with all these display units, speakers, ANMs and everything. Whenever the commands come from MMI to this car controller, this acts as local master and share the data to these display units and speakers for audio visual announcements. And this is a head code display placed above lookout glass in front of driver. So outside passengers who are standing on the platform, they can see the details. And these are bottom one are in-coach displays, double side display or single side display placed inside the coach. Overall, the passengers traveling in the train, they can see the scrolling information. And speakers, Huja make reputed speakers, and these are for audio automatic announcements. And in each coach, there are two ANMs, ambient noise measurement units. They measures the noise level inside the coach continuously. And as per the noise level, this car control defines the next speaker volume. The volume is defined in 3 levels, low, medium and high speeds. Based on the noise level, the speaker gives the announcements. CC send the information to speaker and the speaker gives the announcements, right? This PIS is for automatic announcements based on the data what we fed in the system and based on GPS location. But in addition to that automatic announcements, there is a provision to give manual announcement by the guard. That is called public address system, PA, public address system. So for that public address system, in case of any abnormality, manually also we can give the announcements to the passengers. And one more feature called IC, intercommunication between driver and guard. Driver and guard can communicate each other by using that intercommunication feature. And in latest PIS system, in addition to this, one more feature is given, ETB, emergency talkback unit. Even passengers also can communicate with the guard, can directly talk with guard. That is called ETB, like metro trains. Here also the feature is implemented, emergency talkback unit. Okay. So these are all the features and functions of this PIS, and overall about this MEMU overview. Okay, about MEE 675M, overall functions and features, subassemblies, their functions. Right. So any questions you can raise, sir?
Sir, we are using 3-phase induction motors in 3-phase MEMUs.
Yes, sir.
Which type of induction motor it is? It's slipping or a squirrel cage?
It is squirrel cage.
Squirrel cage.
Squirrel cage
Okay.
induction motors.
Sir, but for initial torque, we use normally slip ring induction motor. Why you are using squirrel cage induction motor?
Here, sir, application point of view, for higher torques that may be required. But in train sets, as per our load and requirements, this torque is more than sufficient what we are using in this application.
Okay, sir.
That is based on the requirement, like, but here for our train sets, it is required, sufficient, more than the sufficient rating is given.
Yes, sir. Thank you, sir.
Yeah. Any more points, sir?
Sir, in this communication failure mode, what is the maximum speed that can be?
Sir, if communication failures, no any limitation. In special RTM mode, it will work up to 110. If FGU also fails, then the speed will be restricted to configured value, that is 55 or 60 kmph.
So what are the feasibilities for communication failure, sir? It may be a parting also, no?
Which one, sir?
Communication failure may be a parting also, no? Then how we can reach that?
Parting means completely the traction will cut off, sir. If it is train parted, immediately all the loops will get open and immediate traction will cut off. So communication point of view, somewhere Ethernet switches or wire broken, lug given up or something, in that cases, automatically it will go to FGU, special RDM mode. If that also fails, then we need to manually change over to RDM mode where the speed will be restricted to the configured value.
But as per rules, sir, front portion has to clear and it must be in running condition till rear portion is come to standstill. Then how will driver will have control, because it will create a collision, no? Still real portion is coming to standstill, front portion must be in traction.
I am not clear, sir. Please tell once again, sir.
Sir, if there is a parting, rear portion also running and front portion also running, no? So still rear portion is coming to standstill, front portion must be in running condition to avoid collision.
Actually, sir, in case of physical partition, simultaneously in both the sides, the brake will be applied. Okay. So there is no question of one should pull the train and other should brake the train. If it is parted completely in train, the traction will cut off. On momentum only, simply it will run, or based on the brake, it comes to standstill position.
If front portion is coming to standstill, rear to rear portion, there will be a collision, no?
No, sir. That is what I am saying. In rear, also simultaneously applying the brake. Where is the question of power in the rear part? We cannot say that only front portion is coming to halt and rear portion is pushing the front portion. Simultaneously in both the parts, the brake is being applied by the system. So it is not, there is no point, such point that one is pushing and other is stopping.
Yes, sir. My one question is that in both traction and braking, DC link voltage should be some different, because when we are applying regenerative braking, then how it can be feedback to system.
Actually, sir, DC link voltage, during motoring, DC link voltage will be maintained by LC, line converter, by taking the supply from the OHE. But during dynamic braking, maintaining the DC link voltage is the responsibility of traction converter by getting the supply from the traction motor. It is not taking from OHE. It is taking supply from the traction motor and converting back into DC, and the same DC will be maintained at 1800 volts DC. Is it clear, sir?
नहीं, मेरा कहना है जब दोनों केस में 1800 वोल्ट डीसी सप्लाई रहेगा, तो कैसे फीडबैक होगा सिस्टम में? How it can be feedback to OHE?
नहीं सर, DC 1800 volts. That 1800 volts is the DC link. After that, the DC link will be given to line converter. Line converter converts the DC link 1800 volts into 950 volts or even more than that based on the OHE, and that will be fed to traction transformer secondary, and transformer step up that voltage, and if the voltage is more than the OHE, then that fed back to the OHE line. That we'll call it as regeneration. DC link will be maintained. हाँ सर, पूछिए.
वही मैं बोलना चाह रहा था ना, जब 1800 वोल्ट डीसी लिंक है, तो फिर 25 के भी OHE वोल्टेज के केस में है 1800 वोल्ट, लेकिन जब हम रीजनरेट करेंगे
हाँ।
तो 1800 वोल्ट से कुछ ज्यादा रहना चाहिए, तब न जो है वो स्टेप अप करके जो है सिस्टम को फीडबैक करेगा।
ना सर, ऐसा नहीं है। डीसी लिंक जो है कॉमन 1800 है, बट मैं आई टेक द हेल्प ऑफ दिस स्कीम एंड देन एक्सप्लेन। वो 1800 वोल्ट्स को जो है यहाँ पे, see here, is it visible sir scheme?
Yeah.
Right. So here during motoring 25 kV supply यहाँ पे स्टेप डाउन होके 950 बन के 915 से लाइन कन्वर्टर से 1800 बन रहा है। वो 1800 वोल्ट्स डीसी को ट्रैक्शन कन्वर्टर 3 फेज एसी में करके मोटर को दे रहा है, राइट? दैट इज मोटरिंग। व्हेन इट कम्स टू ब्रेकिंग, these traction motors generating 3 फेज एसी, और वो 3 फेज एसी को ट्रैक्शन कन्वर्टर रेक्टिफाई करके 1800 वोल्ट्स ही बनाएगा। 1800 वोल्ट से इधर 25 केवी से कुछ मतलब नहीं, बिकॉज ये 1800 वोल्ट्स फिर से लाइन कन्वर्टर को दिया जाएगा, और ये लाइन कन्वर्टर यहाँ पे OHE वोल्टेज को मेजर करते हुए ये आउटपुट जनरेट करेगा कि यहाँ पे 959, फॉर एग्जाम्पल अभी 25 केवी है, इधर 959, 960, 970 वोल्ट जनरेट करेगा। 960, 970 वोल्ट जनरेट किया तो क्या होगा, ये स्टेप अप होके 25 नहीं 25.1, 25.2, 25.3 लाइक दैट वो जनरेट करेगा। दैट वोल्टेज यहाँ पे 25 है, यहाँ पे 25.1 है, उससे ज्यादा, तो ऑब्वियसली ये रिवर्स फेड हो जाएगा वो सप्लाई। क्लियर सर?
ओके, थैंक यू।
1800 से मतलब 1800 के बाद में लाइन कन्वर्टर है। लाइन कन्वर्टर प्लेज द वाइटर रोल हियर टू कन्वर्ट द 1800 इंटू 950 जनरेट करना है कि 960, 970 कितना जनरेट करना है, दैट डिपेंड्स ऑन द OHE वोल्टेज। डायनेमिकली OHE वोल्टेज मेजर करते हुए उससे ज्यादा जनरेट करने जैसा यहाँ पे लाइन कन्वर्टर आउटपुट जनरेट करके ये ट्रैक्शन ट्रांसफार्मर को देता रहेगा। ओके
ओके, यस
Sir,
yes sir.
can you see any log that how much generation is coming?
How much?
How much generation is coming?
Yes sir, exactly, it is there.
Where will see, sir? Because this is the normal
in display we can find in lifetime counters.
in live online only. When the train is on service,
Yes.
pattern we can see.
Directly in DDU we can find in one screen lifetime counters and as well as trip counters, generated power, distance traveled, consumed power, everything we can find.
Raja sir, one more doubt I have.
Yeah, please.
Actually, we had two rakes of MEMU rakes.
Yes sir.
We are giving the, as concerned to the pneumatic equipment, we are giving the same maintenance practice we have followed for the both the rakes. But in one rake, we are frequently getting shock break. Is that a software issue or?
What break you are getting, sir?
Yeah. Frequently we are getting in that particular.
Frequently you are getting what that I am not clear.
That shock break.
Stuck break. Okay, stuck break.
Yeah.
Sir, actually you need to check that what exactly the voltage leakage, this sorry, not leakage, BCP value. In zero condition, what exactly it is coming? It should be less than 0.4.
Okay.
Software is common for all the rakes. Physically, we have to check that values, what exactly it is coming in that individual train. Okay, sir. Any more questions? If no any questions, we can close the session, sir. If any points are there, you can raise. Ja, sir.
Okay. Thank you very much, Rajesh sir, for giving your interactive and informative session.
Okay, sir. Thank you, sir. Thank you all. Thank you all for sharing your valuable time. Okay.
Thank you, sir.
Thank you, sir.